let's get started. Today's goal is for us to simplify trigonometric expressions. We're going to spend 2 to 3 days on this content. Today's going to be a shorter day. Monday's going to be a little bit more involved because that's when the majority of people will be back because there's a lot of people gone right now. So we're going to get to the even and odd identity things in a second here when we get to the negative angles. But right now we start with sine and secant. There are many ways that we simplify trigonometric expressions. I can't tell you a surefire way to do it every time. What I can do is give you multiple approaches and many examples. Here's the first one. Sine times secant. Change everything so it either has a sine in it or a cosine in it. Sine already has sine, so I just leave it. Sine of theta over 1. But I could change secant so that it has a cosine or a sine in it. What is secant in terms of sine or cosine? 1 over cosine, correct? If you don't know that, you have to go to our back sheet of notes, which sits right here, and you can see that secant is 1 over cosine. So those are the pieces I put together for you. If you want to rip that off and have it in front of you, that's fine. But I have 1 over cosine. That gives me sine of theta over cosine of theta. Does that sound familiar? Sine over cosine is tangent of theta. Cool. See that? Try the next one. Cotangent is? Excellent. It is 1 over tangent. But we want to write it with a sine and or cosine. Cosine over sine. So while Terry was correct, the 1 over tangent doesn't help us so much. Whereas cosine over sine does. What happens? Sines cancel and I get cosine. And Terry, just to let you know, in every other class, people said 1 over cotangent or 1 over tangent right away as well. So, and if you don't say it, I always bring it up anyway. Sometimes things don't simplify very well. So secant times cosecant is 1 over cosine times 1 over sine. Does anything cancel? No. And is cosine times sine something special? No. So honestly, it's already simplified from the very beginning. Rewriting it won't simplify it for us at all. Cotangent times secant. Cosine over sine times one over sine, which is cosecant. And please make sure you put the variable in there. Make sure you write theta or x or t or whatever it is. Looks like a non-happy face. There we go. All right. So tangent would be sine of theta over cosine of theta times 1 over sine of theta. What happens? And I get secant. Not too bad, huh? When you feel tired, first of all, if you're not sitting upright, you reduce your oxygen intake by about 30%. If you stand up, take 3 deep breaths. It takes 3 deep breaths to replenish your brain with the oxygen that it needs. And or you can do my tactic, which is as staff means, I stand up. I even maybe walk around quick. So, all right, I'll have you do some work on your own here in a second. But what's different about letter F? What's different about F? You got negatives. So that's where we need to learn about even and odd identities. Okay? So, connect this for you. What kind of graph is that? Yeah, it's y equals x squared, right? Parabola. And then I'm going to look at y equals x cubed, okay? So watch what happens. This is teaching you even and odd identities. If I plug in a positive x Do I get out a positive or negative result? If I plug that same x value in, but on the other side, so that's negative, I get out the same value that I did before, right? That's because this is an even function. And even functions, you get the same thing on the right as you do the left. And so whether you plug in a positive x or a negative x, you get out the same answer. Look at what happens here. If you plug in a positive x, you get out this result. But if you plug in a negative x, you get out that result. They are opposite in value. This is an odd function. This is an even function. You can't look at sine, cosine, and tangent and just know whether they're odd or even. You got to look at the graphs. So I'm going to look at the sine graph. If I plug in an x value, do I get out a positive or a negative? I get out a positive. If I plug in that same x value, but it's negative, I get out a negative result, right? Sine is an odd function. So sine of a negative angle is the same as negative sine of that angle. You get the same value you would if you plugged in a positive. It's just negative in value. So the negative basically moves out front. The reciprocal is the same way. If we consider the cosine graph, maybe you recall that cosine kind of does that, right? Well, it's shifted up one unit, or it starts at the maximum. Yes, no? Got it. You take a nap. Just watch a video later. So we're going to plug in x here, and you get a positive value. If I plug in that same x value, but on the opposite side, you still get a positive value, right? Cosine is an even function. Whether you plug in the positive or the negative, you get out the same result. So cosine of negative theta is the same as cosine of theta. The negative simply goes away. Same thing with secant. You get secant of theta as well. Tangent, if you plug in an x value, you get out a positive. But if you plug in that same x value as negative, you get out a negative. So tangent is an odd function. Tangent of negative theta is negative tangent of theta. So the important thing to remember today is that if you have cosine or secant, the negative goes away. If you have any of the other four, the negative moves out front. So all we have to do is finish off this front page right here. Let's start with F being the negative angles. Never leave a negative angle in trigonometry. Secant of negative theta, what happens? Turns positive. What happens to cosecant of negative theta? Negative moves out front. What happens to cotangent negative theta? Negative moves out front. How many negatives do you have? 2, so positive. No big deal, right? So I will now simplify. Secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is cosine over sine. What happens? Cosines go away. I get 1 over sine squared. When you multiply them, sine times sine is sine squared. You put it right above the n. What is 1 over sine? You get cosecant squared. There you go. Let's try G. Tangent of negative theta over secant negative theta. What does secant of negative theta go to? Positive. Tangent, the negative moves out front. So I'm going to rewrite this. How do you rewrite tangent? So since it's negative, it's got to be either negative sine over cosine or sine over negative cosine. You can't make them both negative, right? Because then it would be positive. So you got negative sine of theta over cosine of theta. How about the bottom? Now what? The negative sign is my answer. How about this one? Cosecant over cotangent. 1 over sine over what do I do? Multiply by the reciprocal. What happens? Signs go away. I'm left with secant. Good. You guys have seen a bunch of good examples so far. I'd like you to try I through L on your own, and I'll post the answers, and you can see what you get. If you don't get the same thing I have, then we can talk about it and see where you made your mistake. Try the last 4 on your own, then we'll give you your assignment. Well, I should have written this instead of cosine of theta. I should have written as cosine of x. That's better. Nobody has any questions? You feeling confident on all 4? Which one? J is one that most people get stuck with, and that would be sine of theta over cosine of theta. Now in the denominator, we have cosine of theta over 1 times, and then cosecant is 1 over sine of theta. So in the denominator right now, I have cosine over sine. So I multiply by the reciprocal. Sine is in the numerator. Cosine is in the denominator. So what's sine over cosine? Tangent and sine over cosine. And what's tangent times tangent? So what do you think the mistake is that a lot of people make when they do this problem? They start canceling them all off. They get 1. So they just get used to canceling. But they don't cancel. They get squared. Okay? Sine squared of theta over 1. Cotangent is cosine of theta over sine of theta. And cosecant is 1 over sine of theta. Well, how many sines do you have in the numerator? How many do you have in the denominator? So those will cancel. You're just left with cosine over 1 or cosine of theta. Bada bing, bada bam, bada booski. On the on the test, these are like the gimme problems I expect everybody to get. Okay, this is the most basic and straightforward examples. They get significantly more challenging. So, so we can practice that on Monday. Part of the reason why I think we didn't do so well on the calculus test is because the majority of the assignments were book assignments. I think people are less likely to check their answers if they're given a book assignment. This unit, I think you have all book assignments. I haven't spent the time of making worksheets for every single lesson, so maybe I'll try to do that for next year. But let's try to check our answers. So 7.1, page 540, numbers 1 through 4, 6, 9, 12, 18, and 21. You can literally get the assignment done before the hour is over.